Assalamu alaikum. Welcome all the students to distance learning program. I am Ms. Shahnaz from South Kent Grammar School, which welcome to another very very informative lesson 2 and video 2, which we are dealing with the chemical energetics chapter 10. Topic is use of exothermic reactions and endothermic reactions. Okay, and welcome students with the learning objectives. In this video you will get what we have learned. I will just give a review for those who stood. I expect all of you have watched my first lesson, but in case you have missed my first lesson, we will just have a review of what we have learned. Then exothermic reactions used to warm food. Endothermic reaction is the main topic of us with different examples and a very short homework about it. No, so let's start our new lesson. What we have learned in our lesson number 1 is the thermochemical reactions, thermochemistry, and exothermic reactions. Thermochemical reactions, everyone know? Yes, what was the thermochemical reactions? The reactions during which material changes, and that material changes were accompanied with the change in the heat. And the branch of chemistry which deals with those reactions with the study of the heat changes in the chemical reactions are called thermochemistry. Then we comes to the most important point, that was the exothermic reactions. Exothermic reactions was those in which the heat is released as an energy that you already have done. Examples were combustion reactions, burning of fuel, burning of methane. All these are the exothermic reactions. So now you well know about the exothermic reactions. Here is the one beautiful example of the use of the exothermic reaction. Mostly for our army, modern army, what they do, they don't carry the stove. They don't know how to carry the stove or campfire like that things. They use that we called as a radiation heater. We call it as a radiation heater in our new language. And what they do, they had food rations in a bag. They carry the food rations in the bag. Now, when they want to have a eat that food, what they do, they put it in the bag. They have a bag also, and this pouch they put in the bag, and there they add the water, and the chemical reactions is going there. So let's watch what is in that bag. Oh, it looks like a very magic bag that make the here food warm. Okay, so here it is. Without a stove and fire, food rations can be warmed. Okay, very basic use of the exothermic reactions. Okay, flameless radiation heater. Here you have a flameless radiation heater, and what is it doing? It is a heater contains chemicals that react with water to produce heat. Okay. A heater contains chemicals. What are the chemicals it contains? It contains mostly 3 types of chemicals. Like I say, it contains iron, it contains sodium chloride, contains magnesium. Okay, but let's see what is going on. In the pouch, the water is added, and when the water is added, the chemicals react with the water, and temperature of the food reaches 60 degrees and it becomes warm, not heated up. It becomes warm in 15 minutes. Time is a little bit more, and the reaction is there. Magnesium plus water, and it gives to the magnesium hydroxide. No, don't hurry. All these are written in your book. I haven't gone out of it. It is written in your book, the equation where magnesium in solid state, it combines with the water liquid and gives to magnesium hydroxide again in a solid state, and hydrogen is released. It is an exothermic reaction, so minus 3.53 calories are released. So let's see what is going on. Iron is also added there. So what is why the reaction is taking 50 minutes? The reaction of water and magnesium is slow. Why it is slow? Because magnesium oxide is formed. A film of magnesium oxide is formed, which avoids further reaction, which avoids the formation of hydroxide. So what we do, we have a trick of it, a magic trick. We accelerate the formation of magnesium hydroxide. How do we do that? We add the iron and ordinary sodium chloride. They both, what they do, they don't interfere in the whole reaction, but they are accelerating the reaction. Okay, and that is called as happens in the flameless radiator. So in the flameless radiator, there is a mixture of magnesium, iron, and sodium chloride. Okay. So what you got from it? That we have a magnesium which reacts with water and it forms magnesium hydroxide, and the food pouch gets warm. Where is the food pouch? Here it is. This food pouch will get warm and the army people, they can eat it. So what a beautiful use of the exothermic reaction. Okay, now let's move to the second one, that is exothermic and endothermic reaction. Coming to the system and the surrounding. And this blue thing is the system, and the flask is the surrounding of it. So what is happening in exothermic reaction? It releases energy from the system in the form of it to the surrounding. Okay, the surrounding gets warm up. Then in the endothermic reaction, the reaction that the system absorbs. Where is the system? The orange color is showing the system. The system is absorbing the heat from the surrounding in the form of heat. So let's see endothermic reaction. Greek word endo means into, absorb, three means heat, and that everyone knows that. If I ask him what is endothermic reaction, everyone can give me the answer now. The chemical reaction in which the heat is absorbed or taken in. Yes, got it. यानी heat absorb कर लेती है, ठीक है ना. A very common example is of ice. Just take the ice out of it and put it anywhere. What is ice doing? Ice is taking in the temperature or heat from the surrounding. Either it is 25-hour room temperature. So it takes the heat, it absorbs the heat, and then it is start melting. That is also a type of physical change in which the heat is absorbed. So you can say that heat is absorbed in this chemical reaction, and the heat energy is represented by delta. Sign is positive. Why it is positive? We will learn more about it. What is the characteristics of endothermic reaction? So what are the characteristics of my students in this class? They are very, very intelligent. They do the homework in time. They have done well in the in their online quiz. So what is that? These are your characteristics. I say the characteristics of 8M. Now, here's the characteristics of the endothermic reaction. What is the main characteristic? Heat flows from the surrounding to the system and the container becomes cold. Okay. Then exothermic reaction, the total energy of the products is greater than the total energy of the reactants. That's also very important point to remember. And the difference energy is the heat supplied to the system from the surrounding. Okay, let's move to the main point, examples. That is our end. Decomposition of water into hydrogen. Okay, there are 2 or 3 examples of decomposition, like decomposition of water into hydrogen, and then we have the decomposition of mercury oxide or decomposition of potassium chloride. 3 decomposition examples, and all the 3 are the endothermic reactions. So what is decomposition? Let's not in the topic, but we can go in. Decomposition reactions, a compound decomposes into 2 or more compounds. Okay, so let's see what is happening here in the decomposition reaction. So I will have to explain you a little bit, and we will enjoy the explanation. Okay, you all will enjoy the explanation. And here, let's have a very beautiful color. Which color we have? Blue. Okay, so we are going with decomposition reaction. And you all know what is decomposition reaction. It is a simple splitting up of the product or the compound into 2 splitting up. So we are splitting the water into hydrogen and oxygen. That is very important. Now both of them are present in the form of gas state. This is a liquid state, and a lot of heat energy is consumed there. So it will be in the plus delta H or plus calories we have here. Delta H will be in the form of plus. Okay. So how much calories are they releasing? They are releasing plus 286 kilocalories. That's sounded very much. Now, you all know that we will go with the mole measurement of it. 1 mole of water is here, and it is going to form 1 mole of hydrogen plus half mole of oxygen. So the fractions are there. And why? Because if we go to the water molecule, we know that water, in the water molecule there is always 2 hydrogen plus 1 oxygen. 1 oxygen combines with 2 hydrogen. So what is here, that we have 1 mole of water molecule forming 1 mole of hydrogen and half mole of oxygen. Okay, you can say like this, if I get it a clear one, that here are the reactants, and they are absorbing the heat energy from the, so it is, this is your system, that is the reactants and the products. And you can say the heat energy is entering air, and you are getting the product. Okay, and these are the your system, and these are the surrounding. From the surroundings you are absorbing or in the energy in it. Yes, as the same thing is happening in this next, in which you have nitrogen in the form of gas. So half mole of nitrogen and combines with half mole of oxygen, and it forms again lot of heat energy is entering, and nitrogen oxide is formed. Okay, so two very basic example, and here not much say calories of it is again positive 90.25. So positive indicates that the products have more heat energy as compared to the reactants, as the heat is already absorbed there. So 2 or 3 more examples we have already done it, and now we are going to move to our starting, and that is where we are. Yes, we were here. We were done the, yes, this one, decomposition of water. 1 mole of water is decomposed into 1 mole of hydrogen and half mole of oxygen. Okay. Then we come to the example number 2, reaction of nitrogen to form the nitric oxide. Done. And the 2 more example, decomposition of mercuric oxide into which converts into mercuric matter and oxygen, and again the heat is added in this reaction, so it is a endothermic reaction. And also decomposition of potassium chloride, in which you have to provide heat. If heat is present there, then potassium chloride is converted into manganese oxide, dioxide, and you require a catalyst also to form potassium chloride and oxygen gas. Okay, then is the electrolysis of water, or it is an endothermic reaction. Heat you are giving to water, and it is get split up into hydrogen and oxygen. So the reaction is exothermic. So a very short video was it about the endothermic reaction. And so don't go away, take out your copies, and let's start doing the homework. 2 examples of endothermic reactions, right? They are their reference. You can take page number 117. Which of the following are exothermic, endothermic process? Don't go anywhere. The clues are there in your slide. Okay. So inshallah, till next video we will be there.